Okay, good evening, students. We are doing a very important chapter, which we told you work and energy. And in this, we have discussed with you, we have defined with you, we have told you what is work. And student, this is a very, very important thing that what I told you, student, work. And we said we are all doing some type of work. You are doing work, I am doing work. You are now sitting on your chair and laptop and listening to my lecture, making notes. So you are doing work. But what is the work which we defined in science or physics, student? What work we said? Tell me, what was the definition of the work? What is work, student? This is a question to you before I begin my session. What is work, student? What is work? Tell me. What is work? What answer you are giving, student? What is work? You said work is defined as force into displacement, right?
Yes, sir.
That means force into distance. There is one more important point, student. I am sitting on the chair. I am sitting on the chair and I am teaching you. Am I doing work? Am I doing work? Tell me. You are sitting on your chair and taking my classes. Are you doing work, student? Yes or no? Tell me. Are you moving? No. Is there any displacement? No. Then what we say that at this point, zero work. There is no work. According to this, work is force into distance. Force has to be applied. Displacement has to be there in the direction of the force, students. You see, the important point is that not only the displacement should be there, but the displacement direction is important, student. So what we define in work, student, that we are applying a force and there should be displacement in the direction of the force, in the direction in which force is applied, student, in the direction of force. This is an important point, student. Note it down. Not only I am talking of displacement, I am talking of direction of the force. Therefore, student, when I defined work, we said F into S is the displacement into cos theta, student. Theta angle was involved. Yes or no? Tell me. Yes or no? Where did theta comes from? And what is the need of the theta, student? Important point. This was very important when we defined work, student, in physics, because students, because consider that, for example, I'm just trying to revise it, student. If there is a, if supposing you have an object, it is a box, student, and you are displacing it in this direction, it is moving in this direction, displacement is in this direction, but you are applying a force, student, like this. You are applying a force. Now this force is applied in this direction, displacement is in this direction, student. If I draw a line parallel to this, student, it looks like this. So this is making an angle of theta, student. This is making an angle. This is making an angle with this displacement. And that is why we said now the force is F, the work done is F into S in the displacement into cos theta, student. Important point, very, very important. Am I right or wrong, student? Tell me. Am I right or wrong? Keep on interacting with me, answering the question. Very
Yes, sir.
okay. Now, what we are saying, you know that cos 90 degree is zero. Cos 90 degree is zero, student. So if this force, if the force applied is perpendicular to the
Sir,
displacement,
your voice is breaking.
my voice is breaking. I am trying to see that my network could be, or some problem could be there, but I am connecting with it and you the video recording. If any word or anything is missing, you can listen to it. So everything will be okay. Now the voice is coming, students. Is the voice
Yes, sir.
okay?
Yes, sir.
Okay, okay. If any breakage in the voice is there, you are having a board is visible to you clearly, students. Board is clearly visible. and you will get the recorded videos also. So the result of this will be, students, that you will be getting all the lecture which we are giving. If anything is missed, you will get complete lecture. As nowadays the load is becoming very high, as large number of students are studying at this time. In the reason is sometimes the load becomes high and the network issue is there for everyone. So we have to face it, student, and don't worry. That is the reason I will keep on providing you recorded videos. Recorded videos will be given to you. If anything is missing, you can and just listen to the recorded video. But my lectures will be very, very important and very interesting, because there will be a lot of data and lot of important facts which will be given, and we will try to see that you understand everything. Therefore, student, what I am saying, work is done on an object if there is a force and displacement takes place in the same direction as the force, or if it makes an angle, student, then we have to multiply with that angle. And if the force applied is perpendicular, is at 90 degree, as at 90 degree to the direction of the displacement. Displacement is in this direction, force is perpendicular 90 degree, 90 degree, then cos 90 will become 0, and work will be force into S into 0, work will become 0. I hope we did that. Many cases you have given me examples of that. Tell me, give me an example when work is 0. Give me an example when work is 0. So you are applying a force, but no work is done. There are so many examples of that, students, that if you put a bag on your head, student, and if you move that bag is on your head, the force is acting downward at 90 degree to the displacement. In that case, we will say that the work done is 0. Or if there is any angle, then we have to put the value of cos 30, cos 60. There is a value which is given in the book, students, which you will learn in maths of 10th also. Cos 30 degree, cos 45 degree, or different angles will have different values. From maths we can get those values. So then we can calculate the value of the work. Therefore, student, I am sitting on the chair. There is no displacement, work 0. I am not doing work because there is no displacement. But the question is, as we were talking about energy, do I have energy or not? Tell me. What is the relationship between work and energy, student? Work and energy have very, very close relationships with each other. Work and energy are very closely related, because no work can be done without energy. Tell me, can I do work without supplying energy? Tell me, if I don't have energy, can I do any work? Yes or
No,
no?
sir.
So therefore, there is a close connection between energy and work. They are like brother and sister, student, that if you have to do work, energy has to be given. When energy is given, work is done. If I have no energy, how I will do the work? Or in other words, if work has been done, then some energy would have been stored in that body. If work is done, then energy is there, student. If you are running, you are doing work because you are now moving, you are displacing from your original position. But what will happen? You have taken and eaten your food. That food is giving you energy to run. And after some kilometer, you are exhausted, you are tired, your energy is finished. You have used your energy. Work has been done, energy has to be given. Without energy, no work can be done. So you know this important relationship. So without, if unless I have energy, how I can do work? No. For example, if this box, student, consider here is a box, student, and if I have to push it, if you are pushing the box, student, who will push the box? Hey, if some person is pushing it, he must have energy to push the box. So we are saying it moves from this position to this position. This is my This is my A position, supposing now this is A. So this is our displacement, student. This is the distance moved in the direction of the push. But the person who is pushing it, some force, who is applying the force? It could be a trolley, it could be a man, then they have to have energy, they must possess energy, student, to do this work. Therefore, the energy was supplied and then this energy gets stored in the object, students. Now, when an energy is stored in the object, that means it can do the work. It can do the work. In other words, student, you are sitting, you are not doing any work. Tell me, are you doing any work? Yes or no? While you are sitting, are you doing any work? Yes or no? Tell me fast.
No, sir.
No, sir. But do you have energy or not? You have energy or not?
Yes, sir. We have energy.
You have energy, but that energy can be used to do the work when you want it. You are not presently using that energy for doing the work, but if you get up from your chair, start walking, that means you had energy. Now that energy is you are doing work. Therefore, we said energy is the ability, capacity to do the work. Or energy can do the work, or energy can be stored. You have stored energy, and when you want, you can do some work. Yes or no? I have energy stored inside my body, students. If I want, I can run. I can do the work. I can lift a box. I am not lifting right now, but if I mean, therefore, student, the energy and work are related. Yes or no? There is a very, very good relationship between work and energy. So much so that work and energy have the same units. Tell me yes or no? What are the units of work
Yes,
and energy?
sir.
Give me the units of work and energy, students. What are the units of work and energy? Fast, 30 seconds. SI unit of energy or work is the same. What was the unit? Tell me.
Sir, joules.
Joule is the correct answer, student. So you see that when you interact with me, you are so strong in science. I was so brilliant at me, but too, you know everything. But we have to use our mind. We have to use our mind, student. We have to learn each and everything. That's my point, student, that the energy is there. Different bodies, they have energy and they have a capacity to do the work, or they can use that energy to do the work, or they can keep the energy stored in them. Energy stored in them. In a fuel, in a petrol, student, there is energy and it can do work, but petrol is not doing the work. But when you start your car, student, when you burn the petrol in the car, students, then what happens, it produces energy and that energy runs your car, it does the work. So energy into work or work into energy, students. If I do the work, then body has got energy. For example, student, what I am saying, see here, this is a object, student. This is an object. This has some mass. It has a mass, M, supposing. I take this, supposing this is a ball. This ball is on the ground, student. I put it to a height H. I have raised this object to a height H. Tell me, work has been done on this. Work has been done on lifting this ball from ground to the height H. Has the work been done? Yes or no? Tell me fast. Has the work been done in lifting this ball from ground 0 to height H, student? Supposing this height is 10 meters. What will happen? Work has been done? Yes or no? Fast. Students, work has been done. The ball moved from this to this position and I put it at a 10-meter height. Now that work which has been done becomes stored in it in the form of energy. Now this ball has got energy, student. Tell me, this ball has got energy? Yes or no? This ball has got energy, students. Tell me
Yes, sir.
where the energy came from, the work which was done. in moving the box, in moving the ball from zero level to height at students? How will you say there is energy? If the ball will fall, student, if the ball falls, what happens? What happens? It, as soon as it falls, it is moving. The ball falls. Or if any object falls on your head from a big height, student, what will happen? It will be a great energy transfer. You will be crushed. Yes or no? So, students, what we are saying that work is done on an object, then that becomes energy stored in that object, and that can do the work at the same time, or it can do the work at some other time. That is why we define energy as the ability or capacity to do the work. Are you sure what I said is right? Does it make sense to you, students? I hope you understand everything. Clear? Now, what type of energies we are saying? You have been told by me, different forms of energies are there, students. What forms of energies we know? If I say there is a fuel, coal, there is a petrol, there is a gas, natural gas, student, it has got stored energy in it. It has stored energy in it. You burn it, it produces heat, and you are able to cook your food, students. Petrol, you burn the petrol, it runs your car, students. These are you have a, you see, battery or a cell. What is there in the cell? Is a chemical energy, students, that is stored in it. If I have a cell as it is not working. As soon as I put a cell in a torch and I put the switch on, students, what happens? Light comes. So that means there was energy stored in the cell, student, and it did the work as soon as I made a connection and the light is on. What type of energies we are talking about, student? That bodies can store energy, student, due to the position, or due to certain configurations, due to certain shapes, students, they can store energy. This type of energy, what I'm going to talk is potential energy, students, potential energy. So last time I discussed the kinetic energy. That energy is the energy due to motion of the body. When a body starts moving, then what type of energy it possesses, students? Kinetic energy. And kinetic energy can do the work. Or work is done, then there is a work can be converted into the energy form. What energy? Kinetic or potential energy form, students. So you can see that what I try to say, told you that we should understand that there are things, students, there are substances, they have a stored energy in them, stored energy in them. For example, I told you the fuels, there is energy stored in them, and when we use them, they can use it. When you ignite them, burn them, the energy is produced. Inside the nucleus also, there is a nuclear energy, student, nuclear energy. It is inside it, and when we do the nuclear reactions, fission reactions, atom bomb is produced, explosive reaction is produced. So atomic energy, student, you break the nucleus and energy is produced. Therefore, what we are trying to tell you that there are different types of energies which we experienced. But ultimately, I decided that all the forms of energy I am putting in two forms: kinetic energy and potential energy. That is what we define. That what I said, there is a mechanical energy, student, which is the sum of kinetic energy plus potential energy. Potential energy, students. And these energies keep on interconverting in one into another, kinetic into potential, potential into kinetic. All this process keeps on going, students. For example, you see, consider this is a mountain, this is a ball here. This, I move the ball to the top, student. This ball moves from here to height h, students. What happens? This kinetic energy, ball is moving. The kinetic energy, once it reaches here, this has got energy now. This has got energy, and it will can fall to. So kinetic into potential energy, potential into kinetic energy, students. One form of energy can be converted into another form. Kinetic energy plus potential energy is called the mechanical energy. Kinetic energy, if total energy is conserved, student, we will discuss that principle. If kinetic energy decreases, potential energy increases, potential energy decreases, kinetic energy decreases. So therefore, students, I hope you are enjoying the session. And now my today's topic is potential energy. You already got a catch of what I'm talking about. Kinetic energy was energy due to motion. Now I'm saying the bodies can possess energy by virtue of their position, by virtue of their shape, by virtue of their configuration, students. I'm saying the energy possessed by a body due to its position, shape, or what I also call this as a configuration. Configuration. This is called, student, potential energy. This is called potential energy, students. Can you give me an example of potential energy, students? You are a part of our lectures. Our lecture is a story, is a film story. You will be participating in it, and we will learn a lot of things from you also, students. Can you give me some examples of energy due to position, energy due to change in shape, or energy due to some configuration, students? Tell me something. Think about it and give me an answer. 30 seconds are given to the students. Okay. Our lectures are going to be very interesting. Keep on interacting with us. Tell me, give me an example of potential energy. Yes, so many are there. If you are, if a book is lying on a table, student, tell me what is the story. If the book falls from the table, was it not having energy? A book lying on a table, is it moving? No. There is no kinetic energy. Then what type of energy it possesses? You are saying it is raised from the ground, student. It has potential energy. Anything you raise
So,
to any other examples?
so, so water stored in a dam has
Yes.
large amount of potential energy due
Okay.
to its
Very
height
good.
above the ground.
Yes. Any other things which you experience in everyday life? You know, you have
So,
seen
a
my car.
stretched rubber band,
Yes, 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 yes. Rubber
it
band is
possesses potential energy.
potential energy. You have a toy car. What do you do? देखो चाबी घुमाते हो, key, rotate the key and leave it. What happens? It starts running. अरे what do you did? There are springs in that coiling spring. As soon as you are winding, the more you wind, the more the car runs. Student, toy car. Yes or no? So where is what type of energy is this, student? These are some of the examples, student, what we are talking. Now you are clear that potential energy is the energy possessed by a body due to its position or shape or its configuration. Student, water stored in a dam has large amount of energy due to the height above the ground. A stretched rubber band possesses potential energy due to distorted shape, students. Gravitational potential energy. See, an apple on the tree, it falls on the ground. Apple falls on the ground, student, and it has what type of energy? It is raised from the ground, student. Gravitational potential energy. As I said, when objects are lifted from this to a higher height, student, they acquire energy. Work is done in lifting this, and then it becomes converted into energy, stored energy, and that stored energy can do the work, student. Again, water is lifted to a higher height, and then that water can fall, and then it will fall. What will happen? It will be able to do the work, student, because there was a potential energy stored in the water. So potential energy is now doing work. Kinetic energy, the body is moving, it hits something, it does work. And when work is done on a body, it starts moving, students. It gets a kinetic energy. So there is a relationship between work and energy and work. That is what we said. So brother and sister relationship, they are equally involved one can be converted into other can be converted into other, and the units are also the same, we told you. So gravitational, there are different types of potential energies which we are talking, students. Gravitational potential energy is that potential energy when you raise anything above the ground, students, to a particular height, then it becomes a potential energy due to gravitational force. The elastic potential energy, for example, now we are taking some activities, students, to show what we are talking about. Take a rubber band, hold it at one end and pull from the other. The band stretches, release the band at one end. What happens? What happens? Rubber band, stretch it. Leave it. What happens? It comes back. So when you stretched it, student, you did work. You did work in stretching. And these 2 points, there is now energy stored in it. As soon as you release it, that energy is there. So what happens? It comes back to the original form, student. So here, what happened? As it moves, kinetic energy, potential energy is converted into kinetic energy. As soon as you release it, it is moving. It is moving. So students, this is what is happening. When you have a rubber band, student, what is happening, you can see these are some of the activities, students. Activities are important to understand the different type of things which we study, students. So what happens, student, that in this case you have performed an activity, and the result of that activity is that you can see energy becomes stored in a body in the form of potential energy, students. So the rubber band will regain its original shape because the rubber band has acquired energy in the stretched position. Rubber band acquired energy in the stretched position. Why? Because you have to do work, student, to stretch the rubber band. You do work on the rubber band, stretch it, you are doing work. So energy becomes stored. That energy is the potential energy, students. Okay, you understood that. Some more activities. Take a slinky as shown below. Ask the friend to hold one of it ends. You hold the other and move away from the friend. Now you release the slinky. What happens? What happens, student? Tell me what will happen in this case. What happens? So this acquired energy, student, when you are just move away from this, what has happened? You are pulling outside, this will acquire energy because you are doing work on it, student. Similarly, if you compress, if this is my spring, student, you compress it, student, compress it, what will happen? Compress the spring, what happens? It will become smaller in size. ठीक है? This is compressed to this form, compressed. Does this has energy stored in it now? Tell me. Has there been energy stored when you compress this? Yes or no? This has now got stored energy. Which energy is this, student? Potential energy. Potential energy. As soon as you release it, it can come back. That spring can come back. So students, we did work on it. The work as a result of it was compressed. The spring is compressed, student. As you can see, as soon as you release, it comes back to the original shape. And when it in the compressed form, there is an energy stored in it, student. So there is an energy stored due to change in shape, change in position, student, uh, of the object, or when you raise an object to a particular height, student. These are different examples of the potential energy. This was an example of elastic potential energy. The other was when you raise to a height, student, gravitational potential energy. As I said, take a toy car, wind it using a key, place the car on the ground. What happens? The car will move. Now, when you have done the winding of the car, student, did any energy get stored in it? Tell me yes or no. What happens? Once you are winding it, student, does any energy gets stored in the car? Tell me. Yes. Which type of energy is stored in the car? This is nothing but potential energy, students. And as soon as you release it, the potential energy is converted into kinetic energy, students. And the toy car starts moving. Is it right? Do you see that? Have you seen this? All these examples, all these activities you can do at home, students. Here we are saying lift an object through a certain height. As I said, what we did, student, here is an object of mass m. You lift it to a height, student, to a height h. Now this object, you have done work and now it has got energy stored in it. It has got energy stored in it. What type of energy stored in this, student? Potential energy. And this can do the work now. It can do work now because energy is there. This object can do the work, student. This is important point. So can do work, student. If raised to a greater height, it can do more work and possesses more energy, students. If I raise to a greater height, if from here I take it to a more height is increased, plus h1 supposing. Now height is more height I raise, then it will do more work, student. It can do more work. But how it will do more work? That means it must possess more energy, students. Then only it can do more work. What type of energy is there in this object now? This is example of what we call this, students, gravitational potential energy. Gravitational potential energy. Tell me, are you satisfied with these activities, students, or you have any doubts? Clear? Or any doubts? Can I proceed further? Students, any doubts or can we proceed further? Sufficient examples of potential energy, student? Okay, let us move further, student. You see that you have used an arrow. तीर कमान चलाया आपने रामलीला में. वो क्या, how it works? There is an arrow, student. As soon as you stretch the string, student, what happens? You stretch it. What happens? An energy becomes stored in it. As soon as you stretch it, student, energy is stored in it. What energy is stored in it, student? Tell me, due to the stretching, student, what energy is stored in it? Potential energy. And you release it, what will happen? This arrow moves with a velocity. That potential energy is transformed into kinetic energy, and what will happen? The arrow goes. So students, your arrow moves. See, you have used it so well. गुलेल, वो गुलेल देखी थी, पक्षी बर्ड्स को मारने के लिए स्टूडेंट्स फेंकते थे उस पे, तो वही है. So students, here are some of the examples of different types of potential energies. I hope the potential energy is clear to us. Can you tell me in 1 second, in 30 seconds, student, what is the definition of potential energy? Fast, 30 seconds. What is potential energy? Students, what is your answer now? Energy due to, possessed by body due to position, change in shape or configuration, or due to height. If it is raised from ground, student, to another height, what happens? then you are saying energy has been stored in it. So some of the examples: gravitational potential energy, river water at the top of waterfall, book on the table, child at the top of slide, ripe fruit before it falls. If the fruit is ripe from the tree, it will fall. What energy is there? It was raised from a ground student. That was potential gravitational energy. Elastic potential energy, we have given sufficient examples of that. Coiled springs, arcs, bow with a string pulled back, stretched rubber band, student soccer ball before players kick them, a diving board just before someone dives. You have seen the divers? बोलो, have you seen divers, student? जल्दी बताओ. स्विमिंग में जो डाइवर्स हैं, have you seen them? Do they use any board, student? They jump on the board, student. The board pushes them. You have seen the type of diving board. You know, there's a diving board, student. You can see them at the swimming pool. Diving board, student. They push it, the board pushes them. So what type of energy is stored, student? When you stand on the board, student, potential energy is stored. As soon as you push it, gives you a push. The potential energy is converted into kinetic energy, and you dive, student, diver. You see how they are diving. This is elastic potential energy, students. Chemical potential energy, as I told you, if you have a battery, student, you have some explosives, or the green plants, student, photosynthesis, there is a chemical reaction which is taking place. There is a chemical potential energy, students. Gasoline is the fuel which is used in the car, student. This is a petrol. So there is a chemical potential energy which is stored. Energy means ability to do the work or to do the work. Either you are doing the work now or you may do the work later. So just as I said, I have energy, but I'm not doing work while I'm teaching you. But as soon as I will finish my class, I will walk outside, then I will be doing work, students. So that is the point. Capacity or ability to do the work is energy. Electrical also potential energy is there. The light bulbs are shining, student. As soon as you switch it on, there was a there was potential energy stored in them, so it lighted up. Your car had light, student. There is a potential energy. You on it, then it lights up. So before owning, the energy was potential energy. It got converted into light energy, students. You got light. Nuclear energy is there, student. Magnetic potential energy is also there. You have certain metals, they are attracted by the magnets. You know that metals are there, but you bring magnetic field around them, they are attracted. So at that time, that potential energy of those metals becomes converted into that field which is attracting them. See, there is energy in them. Potential energy and kinetic energy, as I said, they have a relationship, students. Mechanical energy is nothing but sum of the kinetic energy plus potential energy. All the forms of energies which we experience, student, nuclear, chemical, hydraulic, thermal, heat, or anything, they we are dividing them into parts, students. They are a part of kinetic or potential energy. As something is moving, particles are moving, student, they become kinetic. And when the particles change their position, student, position, they are attracted, student. In the solid, the particles are very closely associated with each other. You apply heat, student, it melts. And then you said it is a latent heat of fusion, sir, because there was some energy stored in them which we called as potential energy. Potential energy was stored due to attractive force between the particles. When you supplied heat, student, that potential energy must be given to them to melt them, student. Before that, melting doesn't take place. So that is why there was a enthalpy of fusion, student, and then the solid was melted at a particular point. When there was a equilibrium between solid and liquid, the temperature became constant, students. So that energy was stored between the particles That was potential energy. Therefore, I can say that the all other forms of energy I am categorizing into forms kinetic and potential energy. Students, we have studied the kinetic energy in the last lecture. Yes or no? Tell me. Tell me. Answer. In this lecture, we are studying potential energy, student. Potential energy. So here, see the balloon, inflated balloon. This has got potential energy stored in it. As soon as you open it, air goes out. Air goes out. And then the balloon goes ahead. Hey, the potential energy is converted into kinetic energy. The balloon flies away. Here is a spring, student. You are doing work on the spring. Compress it. Compress the spring. The spring is compressed. What will happen? Work has been done on the spring. Spring is compressed. Compressed spring has got energy because of the work done on it. What type of energy, students? Potential energy. And it can do work now. It can do work. This potential energy is capable of doing work. So here, this is what we are trying to say, that when I compressed it, I have applied and it was moving. Then kinetic energy. Now it potential energy has stored. Release it, comes back. Potential energy converts into kinetic energy and it moves. It moves up. So these two forms of energy are there. In everything, we can say there are two types of energies which are there, kinetic and potential, and they are can be converted into one another. Kinetic energy increases. Total energy is constant. We are saying if this energy increases, then potential energy will decreases, and the sum of the two will remain same, student. That's what we are saying. If this increases, this decreases. Tell me any doubt up to now, students? You have any doubt? Now the question is, how do we calculate the potential energy of an object at a height? How will we calculate, student? Calculate potential energy when, consider this is an object, student. This is an object here. This is at the ground level. At the ground level, student, object. The mass of the object is m. ठीक है, mass of object, mass of the